Hi, Chris Guzmal here. Today, we're now going to use the partition method as the key ingredient for implementing the quicksort algorithm. We've already implemented partition and a helper method called swap, as you can see right here. And we'll go ahead and just zoom in on them to make it clear what we've got. There they are, partition and swap. They're both static methods, and they're both implemented in main in REPL. And there are some strategies for how to encapsulate this code in a way that you could use it in another class that would be implementing quicksort. But we're going to just copy and paste it into a new REPL. Okay, so I just start here on line 130, select, scroll down, come on. Okay, well maybe I'll just copy partition and create a new, actually here's what I'll do. I'm going to zoom back out so I can actually successfully select the code that I want to copy and paste. So I copy it, and now what I'm going to do is I'm just going to start a new REPL. How do I do that? You know, you click up here, you'd think that there'd be a new REPL option here, but there isn't. I always have a little bit of trouble figuring out how to do the simplest thing, which you do in REPL, which is to create a new REPL, right? But it's one of these very basic options up here. Like there it is, the biggest button they could put. Can't really blame them. So it's going to be a Java REPL, and it's going to be quicksort. Okay. Create that REPL. Let's see, there it is. And it has our usual hello. And we'll quickly check to see if our code compiles by seeing if it does a hello world after we've pasted the code that we copied for partition and swap. So we have partition and we have swap, and now what we're going to want to do is we're going to want to do quicksort. So what we're going to have as our input is going to be an integer array, like we've had before. 3. I'm torn. Okay, so 3141. 3141, right? Very simple array. And the expected result is going to be that sorted, which is going to be 1, 1, 3, 4. Okay. And we can tell that I'm going to want that's the same method that to be borrowed from that other REPL. Oh my gosh, how do I do that? Well, one option, and I'm not sure you'll be able to see this because of the way that the recorder works. I'm going to duplicate my tab, and I'm going to go back to the REPL that I was at before. It's complaining about unsaved changes, but I have this other thing. So I go back to partition. And I don't know whether you're seeing what I'm doing here. It looks like the recording, it still has it. But I just wanted to snag the same method out of here too. And we'll go ahead and snag toString as well. It's not the best coding practice, because here's one of the problems. If I make a mistake on this copying and pasting, then my all the debugging that I did, all the test cases that I created, are kind of like pointless. All right, but I'm doing it anyway in order to kind of show you how to, again, trying to stay in the spirit of ab initio, starting from the very beginning. even though in this case I'm starting from the very beginning and immediately starting to copy and paste code from elsewhere. All right, so this code does run. Note that I'm not invoking toStrings, same, partition, or swap. And what I'd be tempted to do now would be to copy and paste the rest of the code from the other uh, REPL in order to be able to verify that in fact I've successfully and accurately copied and pasted the code I have so far. So maybe it's been kind of a futile exercise, but let's go ahead and invoke quicksort here on A with the arguments 1 and 4. The carbonizers and revest call for this sorts the entire array of size 4. The specification in carbonizers and revest is that quicksort takes 3 arguments, an array, the number 1, and then a number corresponding to the size of the array in the event that you're wanting to quicksort the entire array. This then facilitates implementing a recursive method that does a quicksort of subportions of the array based on the partition method. Okay, so what we expect now is that so if same A expected, then we can do a pass increment, and otherwise, oh, and my timer's going off for my T, so we'll just let it go. I don't think you can hear it. Else fail. And of course our usual printout. Again, more things that I kind of wished I had copied and pasted. So we'll have to have a lesson on appropriate encapsulation, so I don't have to do every video work. I write the same code over and over again. Passed, pass, failed, fail, and once again I need the fields pass and fail, private, static, int, pass and fail. I think those will be happy. Okay, let's see. So this this should complain when I run that quicksort is undefined. Cannot find the symbol for quicksort. That's exactly right. So let's make a stub for quicksort. So we'll do public static. Does quicksort return anything? No, I don't think so. Void quicksort, an array of integers, value for start, a value for end. But note that start of 1, end of length of AR are the standard for full sorting. And we're going to have that interface slightly differently with partitioning, because our partitioning is zero-based, and the fundamental rubric for our being happy about the arguments start and end are that AR of start does not produce an out-of-bounds error, and AR of end does not produce an out-of-bounds error. The CLR code does produce out-of-bounds errors when you do that. So the good news is with a void method, we don't have to have the body of the method do anything at all. So I think now if we run, everything is copacetic except I misspelled system by capitalizing the Y. So I changed that to a lowercase y. Run again. It failed the test. That's not surprising because 3141 is not the same as 1131. And so we are actually quite happy with the results we have so far. We just need to now successfully implement quicksort. All right. So let me quickly check, because well, let me not check. First, I'm just going to write what I remember. Okay. So I know that if we're done, then we would return. Okay, we'll have to check on what that means. Okay, if we're not done, then what we want to do is we want to partition AR for the region going from the start to the end, as specified by Corman, Liserson, and Revest. And this is where we have a problem, because our end value is going to be too big and our start value is going to be too small. So I can subtract one from both of them. Okay, because yeah, I think that's the way my code behaves. That makes things messier though. So one really annoying trick to do would be to just do start minus minus, end minus minus, just in order to meet the specification that Corman, Liserson, and Revest have, which is this is 1 and that's 4, when I want that to be 0 and 3 in our example. Okay, so if I partition with that value, then I have a new value called pivot equal to what partition returns. And we never check to see whether or not partition returns the right pivot value, okay? And so that's going to be a source of potential bugs, even if everything else that we're doing is right. So once we establish what that pivot is, then what we can do is we can quicksort the array from start to the pivot, and then quicksort the array from pivot location +1 to the end. Okay. And so this actually clues us in a little bit about what our termination condition is, because if it is the case that start equals end, or start is greater than or equal to the end, then we definitely need to return. There may be some other condition in which we need to return, and so we'll see. But I'm reasonably content with this implementation as a first try. Let's see if it compiles. Let's see if it runs. Let's see if it passes its quick test. It runs, gets an index out of bounds error. Is accessing index -1. And we see that main called quicksort, which called partition, and so so partition had a problem. So I'm going to stop the coding I'm going to stop the video right now, and our exercise, our mutual exercise, the homework before the next video is to think about and to look at this code and see whether or not we can figure out what our bug is. Then we'll restart the video. We'll do the next video. We'll start at this same place in the code, but at that point in time, I will know better what the current problem is, and hopefully so will you.